Hey everybody, Mr. Morel here, and we're going to talk about homework assignment 7.4, geometric sequences, the recursive functions. So, so far this unit we started talking about linear equations and then talked about how those were, that's arithmetic sequences are a kind of linear equation. And then, what was I going to say? And we talked about two different ways to write functions that describe that kind of a weird sequence. But starting today, you started to see sequences that were different. They weren't linear. We're not adding the same number anytime like we used to be. You're going to miss those good old days. So now we're talking about a new kind of sequence called a geometric sequence. And you guys got really good at recursive functions. So that's where we wanted to start, was talking about how to write recursive functions of geometric sequences. So let's go ahead and start talking about some of the vocabulary we need. A constant ratio is a lot like a constant difference, only in this time, in a sequence, a constant ratio is the number you multiply to go from one term to the next. And a geometric sequence is a sequence with a constant ratio. So in other words, if you have a sequence that's not adding a number, but instead multiplying the same number every time, we're going to call that a geometric sequence. And let's go ahead and look here. Remember, there's two important parts when describing a function. First is you've got to state what the first number is. So in question 3, the first number is 2, and the way we would write that is f of 1 equals 2. Then to get to the next number, you're going to notice here that we are multiplying by 2. The numbers are doubling every time. We're multiplying by 2. So to get a new number, you look at the number before it and multiply it by 2. Alright, so for question 4, the first number is 1. We would write that f of 1 equals 1. Then f of x equals f of x minus 1 times 3. Sweet, let's look at question 5. It's really hard for me to write sentences on the iPad, so I'm going to let you write this as I say it. We know that the first number is 4. So the way we write that mathematically is that the first number, f of 1, equals, negative 4. The first number is negative 4. Then, to move from one number to the next, in case you don't know what's happening here, like, for example, I think you know that we're not adding the same number because these numbers get pretty big pretty quickly. What you could do is kind of like what we were doing before. You pick a number that's not the first number. Let's say we pick negative 256. Then you can divide that by the number before it. So negative 256 divided by negative 64, you're going to find is a positive 4. So the constant ratio, the number we're multiplying by every time, is 4. So we're multiplying by 4 every time. The way that we would write that, I'll do that in green. F of x equals f of x minus 1, which equals, times 4. To get a new number, we look at the number before it and multiply it by 4. Alright, why don't I go ahead and help you with question 6. So question 6, take a look here. The first number is 3. And then to go to 6, and then 12 and 24, hopefully you see that that's doubling. We're multiplying by 2, so the next number is going to be 48. Now, I'm going to do my best to graph this on this iPad, but it's going to look weird. So remember here, this shows you your position, and this tells you the value of the term. So the first number in the sequence, I'm going to put it at x equals 1, and then I put a little dot at 3. Notice here, we're going up by tens. So a 3 is going to be really close to this line right here. The second number is a 6. That's going to be a little bit past halfway. The third number is a 12. That's going to be about right there. The fourth number is 24. So that's going to be, there-ish. The fifth number is 48. And you could even find the next number, which would be 96. So notice we're not getting a line anymore, not the way that we used to. We're getting this curve. It's kind of cool. So f of 1, the first number in the sequence is 3, and then we're multiplying by 2. every time. Let me go ahead and help you with question 8. Question 8, I kind of gave you more blanks, so you got to think your way through. Now, you want to ask yourself, well, of course we're adding 8 to move from 4 to 12. But does it make sense? Like if we added 8 again, that would get us to 20, and the 20 plus 8 is not 108. So chances are, because of the speed at which these numbers are growing, chances are good that we're multiplying by a number. So you could pick a number, divide it by the number before it. 12 divided by 4 equals 3. I think it's worth checking to see if that's true if we're multiplying by 3 every time. Well, 4 times 3 is 12. 12 times 3 is 36. 36 times 3 is 108. And then times 3 is 324. Times 3 again. Oh, I don't have my calculator with me. Hold on, I'll get it. 1 second, don't yell at me. 3 times 324 equals 972. I was close. Okay. Now we can go ahead and graph that, but notice this time we're going up by 100 every time, so that's crazy. The first number is 4, which is going to be really close to the line. I suck at doing this. The next one is 12, which is still pretty close to the line, and then 36, we're going up just a little bit. Ooh, and then we go to 108. It's just right there. 324 is there-ish. Followed by 972, it's up here. Once again, we've got this weird curve pattern going, which is super crazy because we're so used to seeing a straight line. We don't have that right now. Okay, the recursive function. Well, the first number in the sequence was a 4. To get the next number in the sequence, we would want to look at the number before it and multiply by 3. So there you go. That's your recursive function. It's pretty exciting. Let's go on to the next page. Here we've got a couple of practice problems for you. Let me help you with question 10. So question 10, how do I move from -5 to -10, -10 to -20? Well, I could take -20 and divide it by -10, and that's going to tell me a +2. We're multiplying by 2. But remember, when we describe a ratio, that's just a number. You don't want to say times 2. That's not what the ratio is. The ratio is just the number 2. Calling it a ratio implies the fact that we're multiplying. Then the recursive function. Alright, the first number is -5. To get the next number, we're going to look at the number before it and multiply it by 2. Pretty basic stuff. Okay, why don't I go ahead and help you with question 12. I'm going to do all of question 12 for you. So this is really tricky because I know that you guys see that this is cutting in half, or you want to say dividing by 2. But don't forget that the constant ratio is always a number you multiply. So if you don't know just by looking at that what number we're multiplying to move from one number to the next, pull out your calculator. Pick a number, say the number 8, and then divide it by the number before it. So 8 divided by 16, you put that in your calculator, and you're going to see the number 0.5. I prefer fractions. I'm going to ask you to please write fractions with these. So turn your 0.5 into a fraction, and that's just going to be the fraction 1/2. So our constant ratio in this example is 1/2, and you could double check it if you don't believe me. Take 32 and multiply it by 1/2, and you're going to get 16. 16 multiplied by 1/2 is 8, and so on. Okay, so the recursive function. Well, the first number is 32. To get the next number, you're going to look at the number before it and multiply it by 1/2. And again, I know that you could say divided by 2, and that would still be a true statement, I suppose, but that's going to be, if you're stuck thinking that way, it's going to be really a big nightmare in our next homework assignment if you can't break that cycle. So always tell me what number you're multiplying by, because in the next homework assignment, it won't make any sense if you're telling me the number you're dividing by. Okay? Well, I imagine that this video has changed your world, and I'm glad for it. I hope you're able to sleep well tonight and you turn in your homework on time tomorrow. That would be cool. Okay, I'll see you guys later.